Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On. In this tutorial video, I'll go through this May June 2021. This is a Cambridge International 9701 examination suitable for any 16 to 18 years old chemistry students around the world. This is a paper 4, a variant 1. It's one of the longest component paper covering pretty much everything that the students will have learned in A-level chemistry, culminating from the 2 years or 3 years prior to that, the IGCSE and the O-level chemistry content. In this first question, we have this group 2 thermal stability kind of question. This one is telling us that, they have similar thermal stability. We know the group 2 thermal stability of carbonate, that is our fixed assay. This is just extending the concept to group 2 hydroxide, suggest and explain the variation in the trend. So we know that they become more thermally stable down group 2. So group 2 hydroxide, just like group 2 carbonate, they become more thermally stable. So that means it becomes more difficult to decompose them because they are more stable to heat down group 2. Now why is that? Because down group 2, we also know that there are more electron shells, there are more filled electron shell. And as a result, our ionic radii are going to get bigger. So the ionic radii of the M2 plus cations, they become bigger, they become larger, but still the same +2 charge because they're all group 2 metal cations. So if they're all still the same +2 charge, so we can talk about something called charge density. So the charge density of your cation, the charge density of your M2 plus will have decreased, and when that decrease, they become less polarizing effect of the cation on the OH bond on OH minus. So therefore it weakens the OH lesser, and if you weaken it lesser, therefore more difficult to break. And if it is more difficult to break, you require higher temperature, your enthalpy change will become more endothermic, your stability to heat will have increased as well. The question didn't ask for temperature or decomposition, but it will have become higher down group 2. The enthalpy change of decomposition will have become more endothermic down group 2 as a result as well. In part B, calcium hydroxide is slightly soluble in water. So this fact about slightly soluble in water, we use this reversible arrow, and we also talk about something called solubility product. Solubility product is an equilibrium constant for sparingly soluble salt. So it includes that symbol. So there is your Ca2 plus OH minus, so calcium hydroxide solid dissociating in solution to give you a bit of calcium 2 plus as well as 2 OH minus to balance the equation there, as well as the charges there. Of course, we are saying that they dissociate into aqueous ion, but very little of it dissociate as there's equilibrium there. You want the solubility in mole per dn cube, so let that be X. And if that is X, so let that be X. So what we're saying is solubility there. So this is the concentration at equilibrium. That's basically the solubility in mole per dm cube. So how many mole actually dissolve in 1 dm cube? Let that be X. And therefore, since that is 1 mole is to 1 mole, therefore if that is X, we also have X mole per dm cube of Ca2 plus. However, since this is 1 mole and 2 mole, so if this is X mole per dm cube, this is going to be 2X mole per dm cube there. So what is our KSP? Our KSP is the concentration of the aqueous ion on the right, 1 of the Ca2 plus, 2 OH minus, so that goes to the power because the number in front is the stoichiometry that become the power in that equation there. So what happened then is we're going to have X multiplied by 2X, the whole thing squared. This is where students struggle a little bit. That's going to give you 4X cubed equal to KSP. And what do we want? We want X, so that's KSP divided by 4. So I move the 4 to the other side, but that's equal to X cubed. So move the cube to the other side. Now that I move the cube to the other side, it will have become a cube root there. So I just need to put in the value, which is 5.02 times 10 to the minus 6 divided by 4. So do that individually and then cube root that, and you will get that to be 0.01079. But then the data given in the question was 3 sig fig data. So we got to know what is appropriate number of significant figure based on the data that is given in the question. So I should give it to final 3 significant figure there, 0.0108 mole per dn cube to 3 significant figure, just based on appropriate amount of data given in the question. The next one suggests how the solubility of calcium hydroxide in aqueous sodium hydroxide compared to in water. So the only difference in sodium hydroxide is you have extra common ion, which is OH minus, which is the same ion present in the calcium hydroxide. So number one. Number two, so we know that this is to do with common ion effect. So I'm just gonna reason out first, which is part 2. So we said that NaOH dissociate completely in solution. Therefore, I write a full-headed arrow, whereas the calcium hydroxide is a reversible arrow representing partial dissociation. So what happened is in aqueous NaOH, so the OH minus is a common ion. To the OH minus in sparingly soluble calcium hydroxide. I think I'm running out of space there. Maybe I can just delete that and I just write as a whole sentence there. It's a common ion to the sparingly soluble calcium hydroxide. So what happened then is as the concentration of OH minus increases, what happened to the KSP equilibrium? It will shift backward because you want to try and oppose the change. You have a lot more OH minus from there, so you want to oppose the change, you go backward in order to remove the OH minus concentration. So therefore, you will precipitate out insoluble calcium hydroxide, solid, so therefore become less soluble. So common ion effect means that you will make the sparingly soluble salt less soluble. It will start to precipitate out as solid. The solubility decreases as you have a common ion, and therefore that will cause the Le Chatelier principle of equilibrium in order to go against the change there to try and return back or establish a new equilibrium. That's it really for that 7 marks first question there.